Hello there. I'd like to show you a little video that I created and then show you a little physics to go with it. Take a look, if you will, at this video. It's very short, and when I play it, what you notice is it's just a ball getting tossed in the physics lab. Not terribly exciting, but notice it makes a lovely path. What I'm going to do is walk through that video and show you how we can do a nifty little bit of analysis with that video. First thing I'm going to do is place an origin right down here at the beginning. Second thing I'm going to do is track the position of that ball. Now when I do so, you might notice I have some graphs up here. This one says X versus time. This one over here says Y versus time. You can almost see it. And what that's going to show us is the horizontal, or the left-right position versus time on this graph, and the vertical position versus time on the next graph. So again, I'm going to check this ball's position, and I'm simply going to click on it in each frame. And as I do that, notice how the graph is getting populated with data. And I want you to notice the top right graph is showing the ball's left to right position versus time, and the top left graph, the graph is showing how high up in the air the ball is versus time. And you might think a little bit about why those graphs have the shapes that they do, because that's the physics we want to dig into. Of course, this graph is a projectile, and you'll recognize that that's just an object where the only thing acting is the Earth. And you'll, of course, recognize the nice shape that the graph has as you look at it. And in fact, you can see those blue dots track the pattern in the graph that the ball traces through the air. Kind of neat to see. So as we look at the graphs, what I want you to do is take a little time today and think about what those mean. You'll notice, I'm going to make this smaller now, that the top left graph looks a lot like the picture the ball takes as it travels. But I want you to notice it's not. It's just the vertical position versus time. That is, it's how high the ball is up in the air. So if I start over here, you'll notice on the video the ball's down at the left. And as I move across, you'll see the ball gets higher, and then it turns around and gets lower again. And that just tracks right with it. But if you look at the other graph, you might be a little less clear on this graph. This shows how far the ball is left to right. And as time goes on, you'll notice what's happening is the ball is simply getting farther and farther to the right. And the graph shows that as a pretty darn straight line. Now what's neat is to consider the next two graphs below these. And of course those graphs, as you notice, are graphs of velocity. We have an x velocity graph and a y velocity graph. And what you'll notice if you look at those graphs, let's go over here to the x velocity graph first. And let's first of all see if we can find the data. Ah, there it is. Look at that. Hey, what's happening to the x velocity? Not much. It's staying pretty steady. You notice left to right, the ball is moving along at a pretty steady velocity. This pretty much says the horizontal velocity is pretty constant. Now, the y velocity graph looks weird. You can only see a little bit of data. Let's see if we can find the rest of it. Aha! Early on, what's the ball doing? Well, it has a large positive velocity. That means it's going upwards, yes? But as time goes on, that velocity gets less and less and less. And you'll notice an interesting thing happens right here about 0.35 seconds. You'll notice that all of a sudden the ball's velocity approaches 0. If we go up and match that on the upper graph, you'll notice, wow, at that same time, about 0.35 or 36 seconds, the ball is as high as it's ever going to get, but its position, or rather its speed, is almost 0. Now let's take this bottom graph and let's dig into it just a little deeper, because of course what happens with the rest of the time? Well, I'm going to make my graph go a little further down here, and then I'm going to expand the axis, and I'm going to point out, hey, look what's happening in the second part of the time. Well, now we have a similar situation, except the ball continues to get faster and faster and faster, except you'll notice now it's going in a negative direction. So today what I want you to do is look at the shapes of these four graphs and stop and think about what's going on. Now I'll follow up with this in just a minute as we continue a little deeper look at what these graphs show.